Hello students, in this video we see what is a linked list in data structure. Here we have already seen array, or we already know what is meant by array. Okay, so array is one of the data structure where we can store elements of array in continuous memory allocation. Continuous memory allocation means we define one array like this, declare integer n of 10 or 5. Here we need to give the size of array. So 5 elements, for 5 elements memory will be allocated continuously. Okay, continuously memory will be allocated for these 5 elements, and this is the index 0, this is 1, 2, 3 and 4. So this array we already seen, and we have already implemented stack and queue data structures by using array. Now see what are the limitations of this array. We already know what are the limitations, like size is fixed. So arrays are fixed sized and they allocate memory continuously. So in advance we need to know which or how many elements user wants to store. If I allocate 5 size, and if user want some 10 elements, if user wants to store some more than 5 elements, then there is no any space for storing such number of elements. Okay, so or more than 5 elements we can't store inside this 5 size allocated array. So memory shortage problems are sometimes we face. In such cases, if I decide to increase this size, if I allocate 50 size, okay, 50 size array, then more memory we have. But in real time or in run time, if I store only 5 elements or 6 elements, so in advance we allocate the memory for 50 elements, so in that case memory wastage will be there, because we allocate the memory but we are not using that much memory. So exact memory allocation we can't do in array data structure. Okay, so there is a problem because in advance, in compile time, we allocate the memory for this array, and memory allocation will not be done at run time. Means there are such problems regarding this array. But here in linked list we allocate memory dynamically. Means whenever we need to store element, at that time only we allocate the memory. Means when user wants to store one element, then that only in that situation, means at the running time, not at the compile time. In advance we not allocate any memory, but at run time we allocate the memory as per the user choice. This is what happened. See here in linked list what happened. There are we allocate some memory like this. In linked list we call it is a node. Okay, this is a node, and here first part is a data part and second part is link or next part, which is a pointer. This is the single node structure of a linked list. Here in linked list, what is the actual concept regarding this or behind this linked list? We allocate the memory for this node, single node, at run time. Means whenever user gives the choice of inserting element, then only means whenever user want to insert a particular element inside stack or inside queue or whatever the data structure you use, at that time only we allocate memory for this node, and then insert data inside this node and adjust the link part or adjust the next part. Here how linked list looks, here is one node, then we attach next node to first node, then second node attached to third node. Means in linked list these are the nodes. This is the first node, we can point it as head or first node, okay. Or if we implement the queue, then this is the front node, and this is the, if this is a last node, then this is the rear node. Generally in linked list, first node we can say that this is the head node or starting node, and this node is attached to, or second node attached to first node, or we can say that the address of second node is stored inside this link part, or this pointer pointing towards the next node, this pointer pointing towards the next node. And if this is the last node, then there is no any node in front of or next to this node, so we store here null. Null means this is the last node and there is no any further node in front of or next to this node. Now here we can clearly see the memory allocation is not continuous inside a linked list. One element present here or one element allocate memory anywhere inside the RAM or main memory, then second element allocates memory anywhere inside the RAM. These memory are we see the address of this node and the address of this node. There may be a gap, okay. How we can clear this point? See here, if this is the complete RAM, this is the complete RAM, then maybe it can happen, it may happen like one node allocates memory here, then second node allocates memory here, then third node allocates memory here, then fourth node allocates memory here. And how the links we adjust? This is the first node, okay, this is the first node, and this is the first node, and inside first node we store the second node's address. Means how we can say what is the element next to this node. So for that reason we store the address of this node, second node, inside this node. Means we say that the next node after this node, this is the next node, then after this node there is a link, or this next part pointing towards this node, and after this node or next to this node there is this node, okay. So this is the fourth node, and if this is the last node, then there is no any further node present after this node. So this is the last, and we store the address part as null. Here there is no any address, okay. So here our list is stopped here, okay. This is the end node, so we store inside this address null. Null means there is no any address, okay. So if the address of this node is 1000 and if the address of this node is 2000, then actually what I mean to say, 2000 stored here, and we know for storing addresses we need pointer. So here is one pointer where we store the address of next node, okay. Here if the address of this node is 3000, then this 3000 address we store here inside this next pointer, this node's next pointer. Inside pointer we store the address. So by using pointer we can go towards this address and get the element. If the elements are A, this element is A, this element is B, this element is C. Actual data part is here. A is the data part, B is second node's data, C is the third node's data and D is the last node's data. So these are the this is the structure behind linked list. And if the address of this fourth node is 4000, then we store 4000 here. So for every node structure there is partition. Okay, inside every node, inside singly linked list, every node having two parts. One is the data part and second one is the link or pointer, we can say that. Here we store the address of next node. Okay, and we know clearly to store address we need pointers only. So here we take one pointer to store the address of this node. In this way linked list works. And here we clearly see the memory is not continuous, means one node present anywhere, its next node, the next node of first node will be stored anywhere inside the memory. This is not the same like array. Inside array all the elements stored next to previous nodes or previous elements memory, means these are the integer elements and the index are 0, 1, 2, 3, 4. Then if the first element's address is 1000 and if one element allocates 2 byte memory, then second element stored after 2 byte, third element stored after 4 byte. Okay, so first element stored after 2 byte means 1002, second element address is 1002, then 1004, then 1006. In this way continuously memory will be allocated for this array structure or array. But here is not any continuous memory allocation. Where there is a space inside memory, the node will allocate memory dynamically and adjust the links. So this is the linked list where we allocate memory dynamically. If someone wants to store one more element inside this linked list, then we create one node dynamically, means at runtime we allocate the memory for this node. And this is the, if we want to insert this node or this element at the end of list, then this previous link part is null, but now new node is coming and allocated memory, we adjust the data part here, whatever the element user want to store inside this data part. And now this node is the last node, okay, will be the last node. So we insert null inside this pointer and this link will be adjusted to here, means this new node address we store inside this last node. So new node will be attached to previous list in this way. So only we need to do, create one new node, adjust the data part and next part, and attach this new node to previous list. So in this way we allocate memory dynamically for linked list. There is no need to allocate memory in advance like array, which is the limitation of array. We can't understand or we can't assign exact memory, because sometimes there is a memory shortage problem, sometimes there is memory wastage problem. We can't assign the exact size we can't assign in advance for the array. But in linked list we are not allocating any memory in advance. First time 0 byte memory will be allocated, and when user gives the choice as insert element or push element, okay, then only at that time only, at a runtime only, we allocate memory and store element inside that node, and link will be adjusted. If the node is first node only, then this is the first node only. Otherwise, if there are number of elements present inside the list, then we adjust the link only, means this new node